Hello and Namaste. After the completion of the part 1 of Maxima and Minima, we are going ahead with the part 2 with different approach and with different kind of questions in a little difficult way. So find the extreme values of u is equals to x square into y square minus 5x square minus 8xy minus 5y square. So u has been given to us. We have to find out dou u upon dou x. The way what we have to do it, fx, find out fy and equate it with a 0. The same thing we are doing it only because here it's been given to us. Instead of f we have been given u. So we are using with that. So dou u upon dou x is this. Similarly, dou u upon dou y is coming out to be, so we have to just differentiate u with respect to x, which is 2xy square, which is equals to 2x upon 2xy square minus 10x minus 8y. Dou u upon dou y is 2x square y minus 8x minus 8y. So it's just because of the simple differentiation, partial differentiation of u with respect to x and y respectively. After that, we have to go ahead with the s, r and t. So we have to calculate dou square u upon dou x dou y as s, dou square u upon dou x square as r, dou square u upon dou y square as t. After calculating this particular three different functions r into r, t, s square, we are calculating it to take a decision whether the point is maxima or minima. So for extreme values of u, we have to equate those two equations with equals to 0. So if we are equating dou u upon dou x is equals to 0, that is 2xy square minus 10x minus 8y is equals to 0, we are going to get x is equals to in terms of y. So it is 8y upon 2y square minus 10. Now we have the another equation dou u upon dou y, that is 2x square y minus 8x minus 10y is equals to 0. We are going to put this particular x in this particular equation. So we are replacing x by 8y upon 2y square minus 10. So we have replaced that here in this equation. Then after, so if you'll observe here, we have everywhere there is a y into it. So there is a y here, there is a y here, there is a y here, and it is equals to 0. That means what we are going to get it, y is equals to 0 as one of the value of y. Now if you are taking this y is equals to 0 here from this particular equation, and if you are putting this value here in this equation, that is x is equals to 8y upon 2y square minus 10, we are going to get it as x is equals to 0. So that means what we have got one pair 0 comma 0 of this particular. So it's a possible pair of the extremum point. It's a possible. We don't know whether this particular maxima minima lies for this 0 comma 0 at this stage. But yes, we are in a process of doing so. We are just trying to collect all those different pairs of x and y. So we have got till this. After taking this y here, so there are so many few iterations here in between the calculations over here. If you just observe, it is 8y square. So we have already taken this y out from every term. After taking this particular y out, and if you're just going ahead with this 2y square minus 10 the whole square. So we are going to go with this particular equation, that is 16y square minus 16 into y square minus 5 is minus this is equals to 0. That means what exactly we have done it, we have just taken it 2y square minus 10 out from here, and we have just done the rest of the things. So that means what we have taken the LCM of this particular term, and we got it here as this is, again the simplification will gives us like 16y square minus plus will go off from here. This is 80 minus 5y square minus 25 the whole square after expanding. So this y square minus 5 the whole square will gives us is nothing but is equals to 80 the 16. So y square minus 5 the whole square is equals to 16, means y square minus 5 is equals to plus or minus 4. That means what we are getting here the values. So that means y square is equals to plus 9 or plus 1. How can we do that? So it's nothing but like this, y square minus 5 is equals to plus 4. In that case, y square is coming out to be 9. And if you are taking y square minus 5 is equals to minus 4, in that case we are getting y square is equals to plus 1. And these are nothing but the 9 and 1. So we are getting y square is 9 and 1. That means what exactly we are getting? We are getting y, the two values plus 3, minus 3 and plus 1 and minus 1 as the values of y. That means taking these values and putting it here in x is equals to 4y upon y square minus 5. What we have done it from this particular equation, if you are taking this 2 out, so we'll be getting it 4y upon y square minus 5. So we are taking the 2 numerator and denominator out from here. That 2 get cancelled. We have remained here with 4y upon y square minus 5. And if you are putting all these values like y equals to 1, then x is equals to minus 1. If y is equals to minus 1, x is equals to 1. If y is equals to 3, x is 3, and y is equals to minus 3, x is equals to minus 3. So we are just putting this y equals to 1, 2, 3, 4 values and getting the respective values of x. That means, in short, what all pairs we got it? First pair we got it as 0, 0. Another pair we got it as 1, minus 1. Another pair we got it as minus 1, 1. Then the next pair is 3, minus of 3. Sorry, 3, 3 here. And minus 3, minus of 3. So we got all these pairs for this particular question. Now all these pairs we have to understand whether there is some RT minus S square is going to be positive or going to be negative. How can we do that? We try to get it in the table which are the stationary points 0, 0, 1, minus 1, minus 1, 0, 3, 3 and minus 3, 3. And we are comparing it with the R we are aware of 2y square minus 10, S is 4xy minus 8, T is 2x square minus 10 and RT minus S square. So what is the value of RT minus S square after calculating this R, S, T for this particular points? Suppose for example this 0, 0 we have got the value. So this is R value. I'll just explain one. Rest of the things follow the same in line. So it's 2y square minus 10. If we are putting x is equals to 0 and y is equals to 0 in R, so we are getting this will go to 0. So we'll remain here with minus 10. So this is what minus 10 we got it. Again this x and y is going to be 0, means this is x is 0, this y is also 0. So this s is coming out to be minus 8. Same thing is here, this x will move to 0. That means this is t is equals to minus 10. Now RT minus s square. So R is minus 10, t is minus 8. And this s is minus of 10, the whole square. So that will, this particular value or this particular calculations will give rise to 36. Now this is what is the calculation for 0, 0 pair. The same way we will get it for 1, minus 1. Just pause the video. Try to get all this particular pairs of the equation. So you can just check it. Here RT minus S square, the value we got it as negative. If you'll observe here, so this 36 is the value which is going to be positive here. This is negative. Similarly, this value also we got it as negative. Let us check for 3, 3. 3, 3 also we got it as less than 0. Minus 3, minus 3 also we got it as 0. That means all these rest of the 4 numbers. So this is negative. This is negative. This is also negative and this is also negative. That means what we are going to reject this and this pairs for the possibility of any maxima or minima at these points. Yes, but we are going to qualify 0, 0 for the value. Now we have to check what is it. At this particular point 0, 0, if you'll observe R is negative. So if you'll observe R is less than 0, similarly you can check T is also less than 0. That means what? The origin 0, 0 is the only point at which RT minus S square is greater than 0 and hence the function is maximum at the origin. So what's the value of this particular? So if you'll observe u is equals to x square. So this is what the value of u or the function is being given to us. And if you are going to put the value as x is 0, y is 0 everywhere, so you are going to get the maximum value of the function u at 0, 0 is equals to 0 because there is no constant term here, and at 0, 0 we are going to give rise to this u is equals to 0 everywhere. This is what is the another approach, or this also can be the one of the approach to just write down this in a tabular form. Just do it in this way so that this can be done for all the different pairs of this particular equation, because R, S and T, this value will remain the same for all the pairs. Yes, but that would be changing according to the values of the x and y, or the pair of x and y. That's the reason we can just have this particular decision maker statements in the tabular form as well. Okay, and this is a self-observation slide wherein I have given you only one question. In fact, it says show that the function f is maximum at minus 1, minus 1 and its minimum at 3, 3. So for the hint purpose, I have given you this also, like 4 possible extremum points we are getting for the function minus 7, 3, 3, minus 1, 5, 5, minus 1, and the answer has been given to you as this. So this is, you can consider as a hint. This as the hint you can consider, and these are the final answers for this particular value. Okay, and this is what is all about the particular part 2 of Maxima Minima. There is one more part. 3 is lined up in the next few minutes. Thank you. Happy learning.